The starting point for many consultants on a design team is to link to an architectural model that has already been created. We can use the Link Revit tool that appears in the Insert tab to link to a Revit model file. Be sure to choose the Origin-to-Origin Position option to make sure your project coordinates are aligned with the linked model. The linked model appears in your project, and you can pin it to make sure that it isn't accidentally moved. Next, we'll copy some elements from the linked model into our host project to help us get started with our design. Use the Copy Monitor tool in the Collaborate tab and select the linked model. Then we will set the Copy Monitor options to define how we'd like each of the elements copied in. For the levels and grids, we won't make any changes. For the columns, we can choose new types, but we'll leave those as is for now. For walls, we could choose any of the types available in our project, but we'll leave those as is also. And for floors, we'll again accept the defaults. Now that we've set the options, we can select the items to be copied in. Let's use a drag selection to copy the entire project in this elevation view. Then we'll filter the selection to remove the walls. Let's apply and click OK. Then we'll click Finish in the options bar to complete the selection for this view. You can ignore any warnings about the floor openings. Next, we'll switch to the south elevation and do a drag selection. For this view, we'll uncheck everything except the grids. Because we selected those items in the last view. Again, we'll click Finish to complete the selection. Now we can go back to the Copy Monitor tab and click Finish to copy all the selected items into our host project. Let's also copy in the retaining walls at the lower level. Use Copy Monitor, then use the Copy option to select those walls and copy them in one by one. Having copied in the elements we wanted, we can now create some working views for our structural design. Let's start by creating a default 3D view. We can duplicate it and create a new view where we hide the linked model. I'll give it a meaningful name, renaming it. And we'll use the VG shortcut and go to the Revit Links tab and turn off the visibility of the linked model. This view shows only the floors, walls, and columns that were copied in from the linked model. Now let's create some plan views for each of the levels. We can use the Plan Views tool to create structural floor plans for each of the levels in the project. They'll appear in the project browser under the Structural Plans section in the outline. We'll use the Visibility Graphics overrides to turn off the linked model in each of those plan views, so they'll be uncluttered and ready for our structural design tasks. As a first step in our structural design, we should confirm the locations of the grids and the columns placed in the architectural model, and make any adjustments that might be needed. We'll start by taking a look at the linked architectural model. We can use the section box to cut away the south end of the building so we can see the columns and the position of the corridors on the upper floors. Based on this, we might decide that the north-south grids for the interior column lines should be moved to line up with the corridor walls above. Let's open the Level 1 plan view, and we can select a grid and enter a new dimension to move the grid to align with the corridor. Revit warns us that we're moving a shared element, and that's okay. We'll move the second grid to match the width of the corridor, and again we'll see the warning and use the escape key to close the warning. Next, we'll start by adjusting the columns that have been copied in from the linked model. These were copied in as wide flange columns, and we'll change their type to concrete columns. Select all instances in the view, and then we'll edit the type and load in a concrete column family of the type we want. There in the structural section of the library, in the columns folder, and finally in the concrete folder, we'll choose concrete square. Let's change the size to 18 by 18 inches by choosing another type, and now our concrete columns are in place. Next, we'll place some concrete beams between these columns to support the floor above. Let's move down the top surface of the section box to clip away the upper floors. Then we can also hide the floor element in this view so we can clearly see the tops of the columns upon which we're going to place the beams. Next, we'll use the Beam tool and load a concrete column from the Structural Framing folder in the Concrete section of the library. Let's duplicate one of the existing sizes to make a 12-inch by 12-inch beam. And of course here changing the depth to 1 foot, or 12 inches. Then we'll turn on a 3D snapping tool and set the placement plane to level 1. Now we'll zoom in and hover over the top of a column until a square box is shown to indicate the column endpoint is selected, and we'll click as the start point of our beam. You can also see this in the status bar here at the lower right. Click to place the start of the beam, then click again on the end point. We will repeat this to place beams wherever they're needed. Next, we'll change the floors that were copied in from the linked model to our structural floors. We'll start in the 3D structural frame view with the section box moved up and the first floor revealed. Let's move up the top of the section box to show all of the levels. Then we'll use the Reveal Hidden Elements control to unhide the floor that was hidden at level 2. Select the generic 12-inch floor at level 2 and let's edit its type. We'll duplicate this type and call the new type Concrete Slab 8 inches. Then we'll edit the structure for this type, choosing Cast in Place Concrete for the material and setting the thickness to 8 inches. Click OK to create this new type. Revit will warn us that we're changing the thickness of a shared element, and that's okay. Click OK to close the warning. We're now ready to model the wooden structural elements at the upper floors of the building. Let's start by placing the wood columns. We'll use the Structural Column tool and load a new type from the library. It's in the Structural Columns Wood folder. Let's load a timber column. This family has several types predefined for different sizes. We'll choose the 6x6 and make it available in our project. Next, we'll place these 6x6 wood columns using the Structural Column tool. We'll confirm the placement options to place these from level 2 to level 3 and use the At Grids option to place columns at grid intersections. Select all the numbered grids using the Control key to add to your selection, then grids A and B in the vertical direction. Click Finish, and 6x6 columns are placed at all those intersections. Let's zoom in on the exterior columns to see them better. Then we're going to use the Align tool to line up the exterior faces of these columns with the edge of the floor slab. For the corner, we'll do that in two directions. For a typical edge column, we'll do that in only one direction. And let's lock each of those alignments into place. We can repeat this for all of the columns we placed that are on the exterior of the building, that are on the exterior walls of the building. Now let's look at these columns in the 3D view. We can zoom in on the corner, then use the Beam tool. We'll load a new beam family from the Structural Framing Wood section of the library. We'll choose a glulam beam and choose a 5 by 22 inch from the types that have been defined. Click OK to load it. Then we'll set the placement level to level 3 and use 3D snapping to place these beams at the tops of those wood timber columns. We'll place these along grid line A. Now let's open the Level 2 ceiling plan where we can place and view items above the cutting plane. We'll use the WT shortcut to tile and see both views side by side. We'll right-click on one of the placed beams and use the Create Similar command to place more beams of that same type. Choose Level 3 as the work plane for placing these new beams. Then click on the starting and ending point in the ceiling plan view. We can place one beam after another this way, until we finish all of our beams on grids A and B. Returning to the 3D view, let's adjust the elevations of the beams. We can right-click on one beam and then use the Select All Instances to select all of these beams in the view. Then we'll set the start level offset and end level offset for these beams to -3/4 of an inch to lower them and leave room for a 3/4 inch plywood floor on top of this floor framing. If we zoom in, we can see that the tops of these beams have been lowered just a bit. We're now ready to add a system of regularly spaced joists that will span between the beams we've already placed. Let's switch back to the Level 2 ceiling plan view and open the Beam System tool. We'll leave the work plane set to level 3, so the new joists will be placed at that level. This time we'll set the elevation to -3/4 of an inch to leave room for the plywood floor before we place the joists. To draw the boundary for our system, let's choose the Pick Supports tool and click on the beams we placed. Then we can choose the Pick Line tool and select edges of the floor slab to draw the other boundaries. We'll be careful to go around the atrium and elevation shafts. And finally, we'll use the Trim tool to clean up and join all of these segments into a single continuous boundary around the entire area to be filled by the beam system. To finish the boundary, we'll choose the Beam Direction tool and select which edge of the boundary the joists should run parallel with. We could have chosen either the boundary at the south or the north end. Now we can specify the spacing and the members for our beam system in the Properties palette. We'll use the fixed distance as our layout rule, but change the spacing to 2 feet. Then we'll change the beam type from these wide flange beams. The joists that we want to use aren't loaded yet, so we'll go to the Import tab and load the family from the Structural Framing Wood section of the library. Let's choose these open web joists and load in the types that are 14-inch and 16-inch tall. Now we'll choose these from the Beam Type pull-down menu and click Apply to lock in our selections. Now we'll switch back to the Modify Create Beam Systems Boundary tab and click the check mark to create our system. Let's wait a few moments as Revit creates all these elements. Let's switch back to the 3D structural frame view so we can see that system better. Here's our beam system of joists at 2 feet on center. We're now ready to model our plywood structural floor. Let's start by moving our section box up just a bit so the floor at level 3 will be included. And we'll use the Reveal Hidden Elements control to unhide the generic floor that was copied in from the linked model. This is the generic 12-inch floor. We'll select it, then choose the plywood floor from the type selector. You can see the ghost of the beam system through the floor element because they are so close together. But if we zoom in, we can confirm that the joists are present and just below the plywood floor. Now that we've created all the structural elements on level 2, we're ready to copy these elements up to similar locations on levels 3 and 4. Let's open our level 2 ceiling plan and we'll use a drag selection to select all the elements. Then we can use the filter tool to limit the selection to only the structural columns, beams, and beam system placed in the last steps. We'll choose the Copy to the Clipboard tool in the Modify tab, then paste Aligned to selected levels and select levels 3 and 4. When we switch back to the 3D structural frame view, you'll see that the columns, beams, and beam systems have been copied to similar locations on the other levels. Let's change the generic floor on level 4 to the plywood type. And with that, we're done with our modeling of the wood framing elements for the floor systems. Now we're ready to model the structural walls and foundation elements. And we'll start by creating some interior shear walls at the building core, around the stairwell and central lobby. Here from the 3D view, let's move down the top of the section box so we can see the elements at level 1. Then we'll adjust the visibility graphics overrides to turn off the visibility of the structural walls and turn on the non-structural walls in our host model. Then we'll switch to the Revit Links tab and turn on the visibility of our linked model so we can review the locations where these structural walls were placed in the architectural model. And when we zoom in on the 3D structural frame view, we can see that walls have been placed on each side of the central lobby, and these are the ones that we'll be replacing with shear walls to resist lateral forces. Let's open the structural plan for level 1. Then we'll use the VG shortcut to open the visibility graphics overrides for this view. Again, we'll switch to the Revit Links tab and turn on the visibility of the linked model so we can trace the locations of the walls placed there. Let's zoom in on that building core area where we'll place our structural walls. Switch to the Home tab and open the Structural Wall tool. Now we'll edit the wall types to create a new type with the properties we need. Let's duplicate the generic 8-inch wall and call this new type Concrete 6-inch. Then we'll edit its structure. We'll use Cast in Place Concrete. and we'll set the thickness to 6 inches. Click Apply to lock in these settings, then OK. Now we'll adjust the settings in the Options bar so the top constraint for the new walls will be level 2. Now we can draw our new wall right on top of the one in the linked model, clicking its beginning point and its end point. We want to place a similar wall on the opposite side of the building core, so we can use a reference plane that was placed through the center of the building in the linked model as an axis to mirror this wall to the opposite side. Returning to the 3D view, if we use the VG shortcut and turn off the visibility of the linked model, we'll be able to see the new structural walls that we've added to our host model. Now we'll turn our attention to the lower level and change the types of the walls that will be below grade to retaining walls. We'll change the walls at the sides and the rear of the lower level to be retaining walls. Let's choose one of these walls, then use the type selector to choose retaining 12-inch concrete as the new type for this wall. The top and bottom constraints were copied from the linked model, so the new retaining wall already has the right settings. Revit will display a coordination monitor alert because the thickness of a shared element has changed. Next, we'll place some foundation elements to support our structure where loads are transferred to the ground. We'll start with the foundation slab under the lower level. This was copied from the linked model as a generic 12-inch floor. Let's switch to the Home tab and we'll use the Foundation Slab tool to create a new foundation that will replace the generic floor. We'll use the Pick Line tool to draw boundary lines at the edges of the existing floor. Let's adjust this edge slightly using the Align tool to move it from the face of the wall to the edge of the floor and lock it to that edge. Now we can use the Trim tool to clean up the boundary and form one continuous loop. Let's return to the 3D structural frame view. Having created the new foundation slab, we can now delete the generic floor. We may have to tab a few times to select it and then delete it. Again, we'll get a coordination monitor alert, in this case because a shared element has been deleted. Let's select the slab and confirm that we've kept the right one. Now let's return to the Home tab and add some more foundation elements. We'll open the Wall Foundation tool, then select a wall to place a foundation under. The new foundation is placed under the full length of the retaining wall at the edge of the foundation slab. Then we'll also create some isolated foundations for the concrete columns. We don't have any isolated foundation families loaded into the project, so we need to load one from the library. They're in the Structural Foundation folder. We'll select Footing Rectangular. Then choose the Add Columns Placement option to place multiple. Set the placement level to lower level. Then select each of the columns. A ghost of the foundation appears under each of the columns selected, but we still need to click the Finish checkmark in the Multiple panel to complete our selection and place the actual foundations. Notice how the isolated foundations automatically merge with the slab and create a single monolithic foundation.